Welcome everybody. Welcome to my talk, GraphQL versus traditional REST API. Good thing is like there's a lot of you here, so it means that the conference is very good, right? Everybody likes the conference so far? Yeah, you're very quiet. I'll take that as a yes. Okay, so first of all, let me introduce myself. My name is Vladimir Dejanovic. This is my Twitter, mail, and blog. If you want to basically talk to me online or basically want to follow me. I'm part of professional IT scene since 2006. In other words, I'm getting paid for developing software since 2006. And over the time, of course, I developed software in many programming languages, many frameworks, many tools. I worked on all kinds of projects, basically on all kinds of methodologies. Basically, you name it, I did it. Also, I'm founder and leader of Amsterdam Java user group. And I'm speaker at conferences. And actually, like since yesterday, I'm also Code 1 star. Something similar to old Java 1 Rockstar, so that's a good thing. But enough about me, right? What this talk is going to be about. First, I'll spend some time on REST. What REST is, what we think when we say REST, and what actually REST is. And more precise, traditional REST APIs. Then, I'll spend some time talking about the GraphQL, what the GraphQL is, what it isn't. And majority of the talk is going to be basically comparison between the GraphQL and the REST APIs. At the end, there will be some time for questions. So if you have any questions during the talk, please wait until the end and ask them then. Okay, so what is REST? Funny thing is that, like, why should I ask this question? We're all building REST APIs for a very long period of time, right? A lot of people are developing REST all the time, so why start with a simple question like this? Well, if we'd really go and ask people and record their responses, okay, what REST is, we would get a lot of different answers, of course, but unfortunately, most of them would be wrong. And there's a simple reason for that. REST has a formal definition since it was part of doctoral dissertation by Roy Fielding in 2000. If you would like to read the full doctoral dissertation, this is the URL. It is a very good read, so I suggest you do it. But it's also a very long one, like real doctor dissertation has to be, So we don't have time for that. So let's try to look at REST like in, compact way. So basically REST is client-server architecture. There is basically a client and there's a server, separation of concerns. Then statelessness. There is no context about the client on the server. So everything that the server needs basically to respond to the client request, client has to send in request. Yeah, to respond, yeah. Cacheability. Server has an option to actually say, okay, this response should be cached for this period of time. And everybody involved in the chain should actually follow that, including the client, of course. Layered system. Client has no clue if it's talking directly to the server or it goes through multiple layers before actually it reaches the server. Think about, load balancers, proxies, firewalls, you name it, things. Code on demand, this is optional. To be honest with you, I haven't really seen a lot of this in real life. It actually means that the server can send executable code to the client and temporarily extend its functionality in that way. Last but not the least is uniform interface. And this is a big part of REST. Simply saying it allows different parts of systems to evolve independently from one another. Now you can say, okay, cool, yeah, that's all very nice, right? Doctor dissertations and theories and everything, But, my boss doesn't care about that one, When was the last time that actually your client, your boss asked, okay, what's the doctor dissertation says about this, They don't care about that. They care about the software, which actually adds some real business logic on the table, solves real problems, right? So let's look REST in real life. It usually means that we have some data source, most common database, which actually has the data. Then we have our application, which actually connects to the data and exposes via some API, which is consumed by front end. Very often, basically the application, what it does is just go to the database, takes the data as it is, and just exposes it as it is to the front end, field for field. Of course, there can be much more complex situations where you actually add a lot of business logic, do transformation, things like that. However, a very common situation is that you just go directly to the database, just fetch the data, and just serve it as it is to the front end. There's even have a special name for that, crude REST APIs. And crude REST APIs are so common that actually people very often forget that the REST is much more. So let's look at a simple example. So let's assume that we're building a blog. And as a blog, of course, we have an author has an ID and a name. Then, of course, we have a post. What's a blog post without the post, right? We have an ID, title, body, and ID of the author. And we're going to have like a little bit more advanced blog. So we'll also have an option of comments, really advanced. And basically, it's going to have ID, text of a comment, ID of the post that it belongs to, and the ID of the author who created it. By the way, I'm going to use this same URL throughout the talk. So all the code examples are on basically this URL at the GitHub. I'm just going to basically go through the different branches. So let's look at the code. So basically, this is my code. This is my Pojo. This is my basically the mapping to the database. And you can see here a few things. First thing first, I have a notation document because I'm using MongoDB because I'm lazy. And you can see that I have here one field ID of a type string and another of name of type string. So it is exactly the same like here, right? One-to-one. You may also notice one more thing, and here's that I have here annotation data. And this comes from Lombok, and this again because I'm lazy, so I get for free getters and setters and all those kind of things. Okay, so let's now look at the author repository. Yeah. So basically, this is my repository for reading the data. And again, I have very little code here. I just extended Mongo repository from the Spring, and I actually let the Spring do the heavy lifting for me. I say, okay, this is repository for a type author, and ID is a string. Okay, so if you look at the post, eventually, okay, so same story, right? I have data, I have document, because I'm lazy. I have ID of a type string. I have author ID of a type string, title of a type string, and body of a type string. And if we go to, and basically this is my controller, and this is actually where I have a real business, so to say, business logic. So I say, okay, I have a REST controller, because again, I'm using Spring Boot, and again, because I'm lazy. And I here say, okay, I have one endpoint, which is going to be /authors, and I'm going to get all authors back. Then I can, of course, ask per ID for the author. Then I can ask for all posts. I can filter it by author ID if I want. I have comments, again, to get all the comments, or I can filter it by post ID. Okay. Oh yeah, by the way, I forgot to start this one. Okay, so let's just wait for this to start, and then we can actually see it in action. Okay, this should be fast. Okay, so if we go localhost, right, 880, authors. Okay, maybe it's now it's up and running. Yeah. So let me just big enough, or should it be bigger? Yeah, just this. Okay. So we get the authors, right? Then we can basically see, okay, let's get the posts. So we get here all the posts, and we can basically, okay, filter them by author ID. We filter it. We can also get the comments. We can ask for the comments. And let's filter it by post ID right away. And it works, right? Well, of course it works. It's a demo. Why would I show you if it doesn't work? But just think about this. Okay, so like I have very crude REST API, and you can already think about, okay, like I can build a website with this, right? So when a user basically first time come to your website, basically you first need to show them the possibility for all the posts. So you would basically hit get me all the posts. You would show them. Then the user click, okay, I want to see this post. Then basically you can either, if you cached the result of the post, can show the date of the post. But at that point, you say, okay, like, but I want to show the author, right? So then you're going to call API, okay, get me information about this author. But you also then want to get the comments, right? So you're going to say, okay, like, then give me also all the comments. So you're going to basically to show one page, have multiple calls to the backend API, right? It's not really performant. And I agree with you, like it's very simple. You would then do what everybody does, look, okay, what your use cases, and start doing like optimization. But you, again, like I think it's crude enough that we can actually think, okay, this can go into production. So let's continue. Okay, so now the question is, okay, we all now know what REST is, but what is GraphQL? What I do when I don't know something is, I assume that you do the same thing, is basically go to the Google and ask, right? And this is what I got. GraphQL is a query language for APIs. Whatever that means, right? So, of course, I continue reading and basically trying to figure out, okay, what actually GraphQL is. And I came with a solution which is very simple. And that is, GraphQL is a specification. Nothing more, nothing less. It is just a specification, and you need to remember this. Because we, as developers, we are mostly dealing with implementations of a specification. In case of GraphQL, it's implemented in JavaScript, Java, Go, PHP, and so on. It's like new implementations are being built every single day. But because they're implementations of a specification, it doesn't mean that they're going to cover whole specification, or they're going to really go by the book. You know, just think about a few years back, you know, like what we had like web standards, but Internet Explorer just said, no, I have my own standards. So you need to be aware, okay, like which implementation we're using, and is it behaving in the way that it should? Of course, I'm going to use the Java implementation of a GraphQL, which is called GraphQL Java. But of course, I think talking is boring, so let's look at the code. Again, same URL, different branch. Okay, so I kill this one. Okay, let's now start it so that we don't forget. Okay, so let's look at the code. Let's first look at author. So if you remember, the author is exactly the same like it was. No change here. Okay, let's look at the author repository. Again, exactly the same code. I didn't change a thing. Okay, let's look at posts. Again, I didn't touch it at all. Post repository, I haven't touched it at all. And that's one of the things that I like with the GraphQL. Basically, you can reuse your whole backend system, and you don't have to touch it. You can just reuse it, which is a very good thing. You don't have to build everything up. Okay, so let's look actually where the real difference is. So I have one file which is called schema, and this is basically the definition of my GraphQL API. Here, basically, I'm going to say, okay, this is the types, basically, that I'm going to expose for the GraphQL API. This is the fields which they actually have, and this is basically something that client can interact with. So let's take a look at this. So I have a type author, right? And it has a field ID of a type ID. This is actually a string, but it's called ID, so it says, okay, this shouldn't be looked by humans. That's the only reason. Then we have a field name of a type string. And you might notice that I have this exclamation mark. What this actually means is that this field is mandatory. So if anybody actually requests to have an author and basically requests a certain field, that field has to be there. It can't be null. Then I defined type post, which has an ID, the title, the body, and the author ID. And you may already guess it looks very similar to the tables that I showed you. It's like exactly the same. Then I have a type, again, comment of a type, which has ID, author ID of a type string, post ID of a type string, text of a type string. And that's it. So these types are exactly like we already saw in my tables. Then we actually come to the heart of GraphQL. And this is this schema. Actually, here I say, okay, above are basically the types that I will have, but here is basically where I define what user can interact with my GraphQL. And I'm going to say, okay, here I have a query of a type query. Query in a GraphQL means read-only. You can actually implement GraphQL to actually change the data, but please don't, because then somebody's going to come and basically hurt you, because like you spend a lot of time debugging your code. So here I defined type query, which has field all posts and is of array of posts. As you can see, like basically in the GraphQL, all these types are exactly the same. So there is no difference from the GraphQL point of view between the type query and all other types. Okay, so this is the schema, but how it works. So let's look at application. Ooh, it's going to be long. I forgot the name. yeah, GraphQL. Yeah. Okay, so basically I have a Spring Boot application. Again, I'm a lazy person. I want to do as little as possible. And here, I'm just defining the servlet in a standard Spring Boot way. So I'm saying, okay, I want to define new servlet. I'm going to basically map my servlet to the endpoint /GraphQL. So any request coming to the /GraphQL is going to be served by my servlet. And okay, let's now look at my servlet, what it actually does. Well, what it does is it extends simple GraphQL servlet. I'm kind of cheating because I'm using GraphQL Java and one other helper, basically the package, so that I get a lot of this boilerplate code, for me. Because again, if I went just GraphQL Java plainly, then I would have to actually do a lot of mapping and wiring from a GraphQL schema to my Java objects. And because again, I'm lazy and I don't want to do a lot of stuff, I try to, give as much work to other people. And with this, basically, also is very nice for demo. So only thing that I need to do is extend this, and here in constructor, basically create this build new schema. And here I say, okay, schema parser, new parser. Here I gave, okay, this is the schema that I already showed you. So I say, okay, I want you, basically for me to actually take this schema and start mapping it to the Java code. Then I add resolver. I'll come back to that later. I say build and make executable. And that's it. And GraphQL Java and the helper functions are going to actually do all the heavy work for me. They're basically going to look into my GraphQL schema and say, okay, this is the schema of GraphQL schema, and start actually mapping it and wiring it to the Java code itself. So if we go back and look at the author, you can see its ID and the name, and the type is author. And if we go back to the schema, it is also ID and the name. And this isn't coincidence. Because basically the name is exactly the same, my GraphQL Java will actually know, okay, this is basically, this type is this POJO. The same thing also for the post, same thing for the comments. It will automatically map them together. The only difference here is, okay, the query. Because if you go back to the query, I don't have a POJO like that, right? Okay, but let's go back here to the resolvers, and basically here we come into place. And say, okay, I know that you will not know how to map this one, so that's why I'm going to help you. So basically, I'm going to provide you with a resolver named query. Again, you see the name is the query, and exactly the same here is also name is the query. That is, again, how GraphQL Java code basically knows how to wire those two together. So you need to have the same name. You can call this, like GeeCON, Prague, whatever. If it's on the Java code is the same name, it will know how to map it. However, please use query so that everybody understands, because these are like some standards way of how the GraphQL works. Okay, so let's look at the query. So basically here, what we need to do is, again, I just implement GraphQL query resolver. And here, look, I have a method called allPosts, which return list of posts. So if we go back to the schema, I have query, which has field, all posts, which expect array of posts. So that's basically how the mapping is done, how the wiring of the GraphQL schema and the Java code happens in real life. Okay, but how that actually looks. So let's take a look actually at our application. Ooh, this is too big. So I'm using GraphQL, which actually is a JavaScript library which you can just put in your application and actually play with your GraphQL API, check if everything works nicely or not. So if I say here, query, and I say all posts, and you might see that I have autocomplete. Then we said you have an ID, we have title, we have body, we have author ID. And I just run it, and voila, I get all results. Perfect. We're now exactly the same level that we had with the REST API, right? But let me show one more thing. So here, if you click, you get documents for free. Documentation is for free. And basically here you see, okay, I have a query of a type query, which has all posts, which return posts. So I basically get whole schema here. documentation. That's actually how the GraphQL actually knows to do autocomplete, because it's aware of the whole schema for the GraphQL. Okay? One more thing that we get for free, which is very nice, kind of, is, okay, we can just delete these two fields, and we get the filtering for free. So first time I saw this, my reaction was, okay, this is nice, but I can also do that very easily with the REST API without any problems. So I hope that GraphQL can actually offer more than only this. Because if it's only this, then it's not really that much. So first, let's look at actually how the GraphQL stands against the definition of the REST. Client server? Well, yeah, I would say yes, because I showed you the server and the client. Statelessness? Well, I used the simple, basically basic Java servlet with some boilerplate code. So yes, like if I write it in the correct way, it will be statelessness. Cacheability? Again, answer is yes. If I do my job correctly, if I don't do any magic, again, it's Java servlet, so it will work. Layer system, yes. Well, code on demand, let's be honest, this was optional, so who cares? And uniform interface, I would say again, huge yes, because I showed you the GraphQL schema. So basically, that's all that you need to do to actually create the server or the client, nothing else. Both parts of the system can actually evolve completely independently from one another as long as they work with the same schema. Not only that, so GraphQL is not only that GraphQL is a REST API, it is very advanced REST API, and I will come back to this point later in my talk. So if we talk about REST, we all know the schema is optional. We don't have to have a schema if we're building basically a REST API. It is extremely good practice to have schema. And I would urge you always, always, always have schema. Either first create a schema and then basically generate the code, or write the code and then get the schema from the code. Whatever you want to do, do it, but please have schema. But again, like if you don't have it, everything will still work. With GraphQL, it's a difference. Schema is mandatory. And this is first big difference between the REST and the GraphQL. So in the GraphQL, you have to have a schema. Again, you have two options. You can do what I did, basically, okay, like I wrote the schema, and basically I wired my Java code to it, or you can basically write the Java code, add some annotations, and then the schema will be generated automatically for you. But either way you choose, you will always end up with the schema. So why is schema mandatory? Well, there's a simple answer for that. With the GraphQL, basically when a client first time basically connects to the GraphQL API will say, okay, here is my schema. Basically here I'm defining how you can interact with me, how your request needs to look like, and how my response will look like. And the reason for that is then basically the client can actually store this schema. For example, like in my case, GraphQL, which then it can actually allow me to do autocomplete, it can show me documentation and other stuff. But it can do some other stuff which is also very important. Before even sending a request to the API, it can validate is it according to the schema or not. So, why send something if you know that's not valid? What's the point? Again, if you're naughty and you basically force your client to send the query which isn't valid, what's going to happen is a GraphQL API is going to say right away, like, it's not valid. So it's basically going to take your request, validate it against the schema. If it doesn't pass the schema, it's just going to send error right away. It will not do any work at all. It will not lose any resources of database connection or anything. And this is built into GraphQL, and this is a very nice and cool feature. If we talk about advanced APIs, we have to talk about H2S. So H2S basically is basically the last layer, so to say, of level of the APIs, where the APIs is self-explanatory, explanatory and exploratory. Like, for example, think about the website. When you go on a website, you only know the URL, right? You don't know anything else. And basically, when you hit the page, then you see, okay, there's the pages, there's basically some menus, there's some links, and basically you can navigate through it however you want. So H2S is exactly the same thing, but for APIs. And this is exactly what I thought, basically, when I said that the GraphQL is a very advanced REST API. So let's take a look at that. So if we go back here to schema, so I have only one change here. And basically, this is my change. So now instead of author ID in the post, I added this field, created by, and the author. So, is it up and running? So let me just see if this is going to work. Okay, so now I can see here. Okay, it didn't start yet. Just a second. Now it should work. Yes, created by. We have name. And it worked, of course, right? Because it's a demo. So let's actually look, okay, what I changed in the code. So if we go back here, if we go open author, no, it's post, right? Yeah, post created by, yes, post Java. I didn't change anything here. Like I don't see here created by field, right? It's not there. Okay, so then maybe I did it in repository, right? When I actually reloading the data. So let's open post repository. No, I didn't do it here either. Okay, but wait a second. I also had a query, right? And maybe I put it there. No, I didn't put it there either. So then how it works? Well, if we open GraphQL entry point, basically, we're actually our servlet, you will see that here I have another resolver. Okay, so let's look actually what that resolver does. So this resolver implements GraphQL resolver. If we go back to the query, you will see it implements GraphQL query resolver. So this is different resolver, right? Also, here we have type which is called post. Actually, what this does is we say, okay, how GraphQL actually does the mapping. So it actually, when it sees the post, it actually finds the post and says, okay, like whenever somebody asks for the post, it's Pojo post. If they want some field, it checks, okay, does that field exist in the Pojo post? If it exists, it just calls the getter. If it can't find that field, like in this case created by, then actually what's going to try is to find resolver like this, where actually we have like some GraphQL resolver, which says, okay, like I'm going to resolve all the fields for the post that you don't understand. And fun enough here, I have a field created by, and it will return the author. And that's it. That's the whole magic how it actually works. Okay. So basically what we had is, in our initial version, we had basically our client, and we have three types, basically post, author, and comment. And the client can only talk to the post, only get information about the post, right? All posts. Then we added this line, basically, which connected post and the author, created by. And then the client can actually say, okay, like give me the post and the author which is actually connected to that post. But why stop there? Let's just continue adding the lines, right? Let's connect author and post. Let's connect comment, post and comment. Comment and post. And author and comment. So we now get like, whoo, crazy connection, right? And basically this is what I was talking about, you know, like it's advanced REST API. Basically we now have like very complex situation. So let's look at it in the code again. Okay, it's version 3. Okay, up and running. So if we open schema. So now I added a little bit more things. So now in author I added posts of array post. Then, of course, we had created by, but now we also have a field comments, which is array of comments. In a comment, we have created by, which is for the author. And also we have belongs to, which will return the post. So if we go back to our GraphQL servlet, we will see that now we have some additional resolvers. So now we have like, okay, we have post resolver, which we had also before. But we also now like added, okay, comments, which will return a list of comments. Then we also have like auto resolver, which actually has, okay, give me all the posts, right? List of posts. And again, like I said, it's again implementing GraphQL resolver for the type author. And also we have comments resolver. Comment. Yeah. Also we have our comments, again, the same thing. Implements GraphQL for comment. And we have created by, return the author, and belongs to return the post. So if you go back here, now we can actually add some more things. So basically, yeah, again, like I need to. So the only annoying thing is that I have to refresh this every time, so the GraphQL actually get the new schema. It's kind of annoying, but what can you do? Okay, so now I can say here, okay, give me comments, and not only that, I want text, but I also want to be created by. So I also want to know actually who created it. And again, of course, it works. Why wouldn't it work? So now if we go back to the beginning of my talk, where actually we said, okay, GraphQL is a query language for APIs. Now you understand it, right? Now you understand the definition. Because like first time when we all saw it, it was like, I give up. But now, hopefully, if talk was good enough, you understand. So this was actually like a real intention of the GraphQL. This was the real purpose for it. So the idea was, okay, you have on one side, you have a client, then you actually put a GraphQL, and then you put a lot of backend systems behind, which actually are all going to speak with the GraphQL. Through the GraphQL, you're then actually going to say, okay, all the resources, all the basic identities types, however you want to call them, basically what I have, these are all connections between them, and then you can actually use the GraphQL, basically query language, to actually request what you want, and the GraphQL API is just going to talk to backend systems, actually like combine all these things and basically send the response back. So another big difference between the REST and the GraphQL is, of course, more than obvious thing, is that the GraphQL has a very powerful query language. And don't be fooled, I showed you only a small portion of it. There's like much more things, basically much more advanced features that the GraphQL query language has, and unfortunately I don't have a time to show it to you. Another big difference is that in the case of GraphQL, client calls the shots. So just think about it. When we are building REST API, we are in full command. We say, okay, this is the endpoints that I'm going to basically give to you. This is the response, how it's going to look like. And this basically, once this endpoint is called with this parameter, is going to fruit this part of the code. So actually, you can do the optimizations and whatever you want to do. Like, for example, if you see you need more performance somewhere, or your users are reacting in a different way, or basically, if your users are calling 5 endpoints, you can create one where actually they just call that one and they get all the compound data. But again, you are in a full control, the guy who building the API. In the case of GraphQL, that's not the case. What we actually say is, okay, I have these things, this is the connections between them, go and play. Ask what you want, how you want, whatever way you want to do it. And you need to keep that always in the back of your head. You are not in control. Client called the shots. Why is that important? Well, if we go back to this very simple example, I have a huge problem here, really huge. So you might say, okay, what's the problem? Well, I have cycle dependency, which actually means that somebody, by mistake or on purpose, can actually write some query like this. Again, you can say, okay, what's a big deal? Well, this is a big deal, which means that actually this query can go indefinitely long. And let's be honest, if you run some long query like this on my current implementation, it's going to crash for sure, because it's not protected. It's very simple, but again, it can be taken down very easily. Okay, so then what should we do? How can we actually protect ourselves from the abuse? Well, there are a few ways that we can do that. And again, here comes back, okay, which implementation we're using, because maybe implementation that we're using already has some protections baked into it, or maybe none. So the simplest thing that we can do is we just say timeout. After a certain period of time, we just send to the client, okay, sorry, taking too long time, timeout. The good thing about this one is it's easy to implement. The bad thing about this one is not really going to protect you. Because again, like if somebody sends you like ridiculously long query and you time out him, your server is still burning the CPU and the memory and everything. You're still going down. So it's not really protection. What the better thing that we can do is do the max query depth. Again, like I said, when the query comes to the GraphQL API, it basically checks, okay, is it valid according to the schema? But you can do additional checks there very easily. You can say, okay, is the maximum depth query of max depth of a query bigger than a certain number? If it's just yes, I'm not going to do it. It's just going to take me too much time. Again, depending on the implementation which you're using, maybe it's already implemented, maybe not. Depends. That's why you need to know. this is better protection, but it's still not going to protect you from the width attack. If somebody just really tries to go with a very short queries, but which really go attacking in width. That's why it's a better solution to use max query complexity. Again, for every possibility in a query which you actually have, you can say, okay, this is the score of it. This is how complex it is. When you actually analyze the query, you sum all those numbers up, and if it's above a certain number, you just say, sorry, it's just going to be too heavy for me. I'm not going to do it. It's much better protection, but again, it's much more difficult to implement. The best possible solution that actually you can take, but again, it's most complex to actually implement, is just do the throttling. So for every request, you just give a certain amount of CPU and memory in certain interval of time, and then basically if somebody says ridiculously long query, you just, he's going to wait for a long time. But again, look at the implementation that you're using, look at actually how they did it. Are there hooks there for you that you can actually very easily use, or is basically already they took care of for you? Okay, so as we said, the GraphQL is a query language for APIs, and it consists of three big parts. First part was basically something that I was talking so far almost, and that's the query. That's read-only data. The good thing about the query, because it doesn't change the data, doesn't matter how many queries you get, you can run them all in parallel, because they will not change the data. But we all know that if we can only read data, it's not going to be fun for a long time. So we also have mutations, basically a way to actually change the data. So let's quickly look at that one. So again, the same URL. Ooh, I didn't stop this one. So we're now going to wait for this to stop. Okay, hopefully it will be fast. Yeah. Okay, so let it run up. While it's running up, let's actually look at the code. So if we go to the schema, you will see a few additions. First thing is, to the post, I added this method allAuthors, because I'm going to now basically change the author, so I want to show you that actually it really works. But also in the schema, I added this mutation, again, of type mutation. Again, like I said, same like a query. You can use whatever name you want, but please, if you're reading data, use query. If you're changing data, use mutation. Think about the person who's going to come after you. So in the type mutation, we have an add author. And here, basically, we're adding parameter, which is called name of a type string. And it will return the author. We also have remove the author, ID, and also it's going to return the author. If we go to our Java code, the only thing basically that we did is we added, again, new resolver called mutation, which is going to implement GraphQL mutation resolver. So again, the most of the heavy work is already done for us. We just need to basically just do this, and the most of the work is already done for us. We don't need to worry about the boilerplate code and all those kind of things. And here, of course, we have a method basically called addAuthor, which is taking one parameter of a type string by the name, and it's going to return the author. And again, we have remove the author, which is taking ID of a type string and returning the author. So if I go back here, and if I just do this, I also need to speed up a little bit. So, okay. And if I say, okay, all authors, and give me ID, and give me name. So basically we have two authors, right? And now, okay, I want to say mutation, author. Let's just check if that's the one that I actually removed. Yes, it is. And if we go back to the query, all authors, ID name, voila, we really deleted the data, right? So again, the fourth also or fifth demo also works. So good for me. All demos work. Yeah. My hello world is always so good. So the third part of a GraphQL query language is subscription. And this is a little bit different between of the query and mutation. So I didn't talk about the history of the GraphQL, and it actually came from the Facebook. So what actually this does is client sends certain basically subscription query. It's okay, I want to know about this information. And whenever this kind of information change, basically the server is sending back information to the client. So again, because it came from Facebook, it's very easy to think, okay, it's probably on a mobile phone or anything like all the updates about the post from your friends and all those kind of things. Again, important thing about implementation versus specification. Subscription was in specification a long time ago, but in GraphQL Java, it was added I think about June or July, something like that, because when I actually started giving this talk, this part wasn't implemented in the Java world, but nowadays it is. So again, think about, okay, which implementation I'm using, what are the limitations. So now that actually we spent some time on the GraphQL, there are some maybe questions that you might ask yourself. The first question is, okay, but what do I do with errors? How do I deal with errors? Well, the good thing about the GraphQL specification, it means that somebody probably already thought about this. So if we take a quick look, here I sent some query, right? You will see here I have a data, and inside the data, basically I have the data which I requested. So what happens here if I send something which I know it's not valid? Look, I get data, which is null, and then I get the error with a long description of an error. This is by default just standard way of errors. Again, there's hooks and ways that you can customize this, extend this, do whatever you want with this. But again, it's very easy. If there is an error, it's going to exist. If not, it's going to be only data with the data. The next question, okay, what do we do with the performance and caching? Because again, just think about my use case. What happens if I have one author which wrote thousands of posts? And then I say, okay, give me the posts, and for every post, basically give me the author who actually wrote it. What my implementation is going to do is going to actually call get me the author 1,000 times. Because again, GraphQL doesn't really care about performance and caching and all those kind of things. It cares only about one thing, and one thing only. And that is that it actually wires your GraphQL schema with the Java implementation and with the resolvers. Basically to know, okay, if somebody asks for this field or this type, I need to call this Java code. That's it. Everything else is up to you. So basically, you need to think about optimization and all those kind of things. The good thing about that, well, the good thing is that although GraphQL doesn't care about it, it's not really difficult problem to solve in most cases. Because if you think about the traditional way, what you have a controller which actually calls the service, and then the service which actually calls the database, right? And basically on a service level, because it's statelessness and singleton, you actually do the caching layer. So you can actually do exactly the same thing here. Instead, here you would from resolvers, call the service, again, you have a cache there and you're done. You have to think about it more. But it's not really the end of the world. Okay, what do we do about authentication and authorization? Does GraphQL help us with this? Well, again, you need to look at your implementation, but in most cases, the answer is no. You need to think about it, you need to deal with it. The good thing is there are basically hooks for you to do it in a very easy way. So what I saw is most of what is done for the custom context. So you basically define the custom context. There's a very easy way to do it. You add all your logic that needs to be there. Then to every method call, basically you add it as a parameter, and then you can just use it and do whatever you want to do. Okay, so let's summarize. Okay, we have 6 minutes. Okay, we're good with time. So let's summarize quickly. GraphQL versus traditional REST API. Well, as I said, the GraphQL is a REST API. It's not really traditional REST API in the way that we all think about it, but in the end, it's very advanced REST API, so they're kind of similar. They're not one-to-one, but there are not huge differences between them. Tools and knowledge are, of course, is a different story. So when it comes to the tools and knowledge about the REST APIs, it's huge. Let's be honest. REST APIs didn't start, appearing in 2000 when Roy Fielding wrote the doctoral dissertation. They appeared long time ago. As a result of that, the tools and the knowledge and everything, all ecosystem around the REST is huge, and we can't underestimate that. The GraphQL is kind of new kid on the block. It's just been around, since 2015. But again, it's getting the speed, it's getting, the traction. It's getting better and better and better every single day. But in the moment, there's of course huge difference still. Another thing that I want to stress out is, a lot of old tricks, from the traditional REST APIs that we already should know and be using every single day, we can reuse them in a GraphQL. Of course, some things you can basically take for granted and just copy paste. For some things you need to basically think a little bit more out of the box, like approach it in a different way, just basically be more intuitive. Again, keep in mind, client is calling the shots, not you. So the client. Also keep in mind basically that the GraphQL in most cases really don't care about the caching performance, authorization, authentication, all those kind of things. So you need to think about them. Again, if you take the implementation which already did all for that for you, then you're good. I spoke that the GraphQL has very rich SDL, schema definition language. I can't stress this enough. So again, like what I showed you is very, very small part of the GraphQL SDL. And like when you want to define APIs, what actually they're exposing, what connections, things like that. You can, of course, in REST we're using Swagger or Open API spec or Blueprint or RAML, all those kind of things. GraphQL beats them all. With the things and possibilities that you can do with the GraphQL compared to them, it's huge win for GraphQL, at least at the moment. It's very easy to do things which in other tools, basically, it's very hard to do. Also, GraphQL has extremely powerful query language. Again, I didn't show you all the features and possibilities of it. It's like really, really huge. You can basically do conditions. Basically, you can do renaming things. You can do if loops. Basically, you can do a lot of stuff which, when you first saw, you just say like, wow, that's really interesting. Again, it's not on a level of SQL, so you can't do the grouping and having and all those kind of things, but it's still very powerful. So this was the references basically for my code and basically for the doctor dissertation if you want to take a picture and you can basically use them later. And basically, that's it of my talk. Thank you. Everybody took a picture? I can move slides. Any questions? Yep, up there.
I have a question about requests. In GraphQL tool, you send like request, and it means it goes like get request.
Yes and no.
If you send mutation and add
I'll show you right now. I'll show you now. So basically, if we do request, and that's a very good question. Basically, that's one thing that I also wanted to know. So let's just go here, and let's send it again, and hopefully it will going to show up. So you see here, it's post. From here, it's post even if I'm reading the data. And first time I saw this, I was kind of scared. Because then I said, okay, like, wait for a second. Like, if I send post and I'm reading the data, it means that I can't lose caching on load balancers, on, like, on proxies, and all kind of other things. Because as we all know, the get can be cached, but the post, because they will not know what I'm actually sending.
So
however,
query go to body.
Yeah. However, yes, it's basically here. Let me show you. So yeah, so basically, params. Yeah, so basically you send this as a body. However, this response, yeah. However, according to the GraphQL schema definition, if I send exactly the same query that I'm sending now for the post, for this GraphQL, and say with the get, it will work. And I tested, I basically used the curl, and basically when I send the queries through the get, it worked. For mutations, you always have to use the post. But for the queries, it's going to work both ways. So it's going to work with the get, and it's going to also work with the post. In this tool, it's always sending the post, so it's kind of misleading, in that way if you just think that this always is underway. Excellent question, by the way. Does that answer your question? Okay, here.
Given the standard tool you've showed, how hard is it to optimize situation where you have 1,000 posts with 1,000 users, so you can reuse the cache of the first user because it's written by different users? So I know I can write some custom code that would do it, but how hard it would be with the standard resolvers?
Okay, I'm not sure that I follow your question completely. So you're saying, okay, like what happens if for my API, I get like 1,000 requests and basically for the post with the same author, right?
No, you have 1,000 posts with each different author.
Okay.
So it should basically create one query for the post and one query for each author, and you can cache it by the ID because it's different author ID every time.
Okay.
How hard would it be with the standard resolvers to optimize this?
Well, I would say, again, it would be exactly the same difficult like with the send REST, because, again, you need to create the query to either the service or to the database. And
no, with REST, I would just do second query with all the IDs, which would mean I have constant number of queries, and I can just include the author in the post.
I'm not following 100%. So, okay, so just let me wrap my head so you see if I understand correctly. So we have 1,000 posts. Every post has different author, right?
Yes.
And we basically say, okay, give me. Basically, we say very simply.
All posts.
Yeah. All posts, right? And basically, for every post, you say created by, and give me the name, right?
Yes. This would create, I think, 1,001 queries with your current implementation. And I'm asking you how hard it would be to create only 2 queries or 1.
Well, again, like I would do this, I wouldn't do this in the GraphQL level, I would do this in the service level. So basically, what I would do in that case, if we just go to query, so instead of basically doing here, like, okay, I'll return all posts and basically do all find.
So now, if you modify this, every time you query for posts, it would query also for authors.
Yeah, yeah, but again, like,
yeah, if
that's why
is fine.
Yeah, that's why I said, like, again, it's kind of different ball game. So it's because, like, in this case, you would know how actually, like, you can really optimize REST very easily. In this case, you have to optimize for everything. So one thing that you can.
Yeah,
you can either cheat, and basically here instead basically like inject already the authors, so you can do that, and then in theory maybe it will work.
I think this is my this is the thing I don't like about GraphQL the most, because if you wanna do some kind of aggregations and optimizations, you have to really understand what's going on and plan out beforehand the queries so you can really optimize. With this, it's okay for like simple stuff, but with really advanced stuff, this breaks down.
Well, yeah, it can come back what's your problem, what you're trying to solve. So I agree with you, like, you know, it can become very ugly very fast with the GraphQL, especially if you don't understand what's happening, and that's true. So the one way that you can actually solve it is basically say, okay, I'm going to really whitelist the queries which are possible or not. But then it's kind of, if you do that, then you're basically taking away of the flexibility of the GraphQL and all the features. So I'm not saying that, and, you know, let's be honest, like, I like GraphQL, but GraphQL isn't the perfect solution for all kinds of problems. So again, like everything, you have to think, okay, what they get, what they lose. You know, like in certain cases, basically GraphQL just isn't the solution, and you should be using that. So maybe, you know, in this case, it would be kind of, I really can't think like right on the spot like solution. I would have to really stop, think about it, and maybe, and then come with the answer to that. Yeah. Well, it won't. But again, like, the question is again, like, what I agree. So your point is, okay, it's going to request 1,000 times to the MongoDB. But again, but again, it's I understand your point. I agree with you partially. So basically, you say, okay, we'll have like 1,000 requests to the MongoDB. Maybe that's not the problem. Maybe that's the problem. Again, for example, if I understood you correctly, your idea was, okay, I would like to just send one query to the database or the rest, whatever, and it's like all the list of the IDs and basically just do in one big query. So again, like I said, like it really depends what's the problem that you're trying to solve. Is it like problem on the service level, or like you said, like are you calling some other system for that, or you basically just want to have one query to the database? I must say, like, you're the first time that I can't really answer on the spot. So great question. Any other questions? I think not. If I'm mistaken, just yell. Thank you once again.